I just want to welcome everyone to our LG technical training, our first one offered this fall. We'd like to welcome you, John Stanton, who will be performing our training today. So it's all yours. Take it away.
Hey, welcome everybody. I want to thank you for taking the time out this afternoon to participate in this class, and I hope you find some value in it. So we're in our facility here in Huntsville, Alabama, and this is our laundry room. So it's kind of messed up a little bit, but it's functional. So it's not like working in a normal situation where you are in a laundry center or a little basement or something, but I think it will do for what we're going to be covering. So today, my agenda is I'd like to cover some of the features on this and then get into briefly install. Because I know some of you guys might install, some of you may not. But in any case, we're usually out there to correct some of the install issues. So it's good to know what's involved in this. Nothing out of the ordinary. And then I want to get briefly into disassembly. I don't have a lot of time to completely tear it apart, but I want to show you the major things, how to get into it and how to service. And more important, when we get into service, a couple things we're going to cover is servicing the electrical components at the board. And we'll show you how to do it. This kind of looks intimidating. We got this great big tower here, and we'll show you an easy way of getting in and out of this. And then last of all, we'll open it up for open questions. Now, at any time, I have a moderator, and his name is Dan, so if you want to go ahead and type in questions or just feel free to chime in at any time if something is unclear. Maybe I can make it a little clearer for you. Be glad to do that. So with that said, what we have here, this is a washer stacked unit, and we call this a tower. It comes in two different types. There's an electric, of course, and then there's a gas. Roughly the manufactured retail price is about $2,500 for the electric unit, and it's about $2,600 for the gas unit. Now the model number on this is WKEX200H, and then of course it gets into your colors. But let's explain what those alphabets stand for. The W is washer. The K, as far as we know, and this might change, but we think the K stands for tower, because that's a new alphabet for us. We haven't quite seen that before, but that's what we're assuming that stands for. The E stands for electric. Of course, if you had a gas dryer, that would be a G. And the X always stands for steam. Both of these are steam unit. We have steam on the washer and we have steam in the dryer. And then, of course, the different models that are available. So let's talk a little bit about feature for you first, okay? So we're going to go ahead and turn this on. This is all capacitive touch, and it's got a unified control panel. Now, the main idea behind building this is a lot of times when you want to stack a washer or a dryer, here's the problem, especially for me. I'm a shorter person, and my wife's a little shorter than I am, and so you can imagine some of the difficulties you might have when you stack a unit on top of each other. Washer is usually not a problem, but the problem is in with the dryer. You take that dryer and you put it on top of the wash machine, and you have to reach way up here to even turn the dryer on or to get to the different cycles. So what they did is they made everything down here easy to get to. And I like this because you can actually open it, and even being a short person like me, I can still really get in here and get my clothes out of there. So let's go ahead and we'll turn this on. I'll start out with the washer first. Okay. Now, most of the time what happens is it sets for the default setting. The default setting is normally going to be normal. I'm going to talk a little bit about that later. But in this case, everything illuminates, so the consumer would have to pick what particular cycle they have. Now, over here where we have different modifier buttons, so some of these buttons could give you a higher wash temperature, or it can give you a different spin speed. And then the last one over here isn't set because we didn't have anything in that particular cycle that would apply to that. So a lot of times when a customer says, how come when I hit this particular cycle and I went to modify, nothing came up? But we realize that some of those things might be detrimental to that different feature. And then we also have different features up here. We've got a signal button so they can turn that on and off. This one is your steam feature. This one over here is your turbo wash. And basically turbo wash will give you a little shorter cycle. But because we use a twin spray system, we use our recirculation pump to take that water, that hot soapy water down from the bottom, and we use to splash it onto the clothes as they're tumbling. So the customer is going to get a shorter cycle. It was designed to save energy, but they're going to get the same kind of wash performance. And then, of course, we have a extra rinse feature, and then we also have a pre-wash. Now, pre-wash will add more time to that cycle, but they can use it if they have heavily soiled clothes. And cycle selection on here is we have normal, we've got your bedding, we've got your delicate cycle, we have your heavy duty, we have your speed wash, and then of course we have a download cycle. Now the download cycle is, these are special cycles that maybe not everybody uses. Maybe you just got a new baby in the family, and when you bought that washing machine, this was somewhere into the future of maybe having a family. So you can go ahead and if there's a specific cycle, let's say for baby wear or for diapers, you can go ahead and download that. Other cycles that you may be able to download are like active wear, if you're into sports or something like that. So there's a variety of download cycles. The only thing I will mention, and you probably get customers that ask you this question, is how many can I download? You can only download one. If you decide to download something else, that one is going to be replaced by that new cycle. Now, both of these units are Wi-Fi, so you can go ahead and you can hook it up to your Wi-Fi network, and that'll allow you to do a multitude of things. You can get onto the power grid with it. We can get into smart diagnosis. We can actually start and stop the units remotely. So you can really, anywhere in the world, you can go ahead and start and stop these things. And we'll cover some of that Wi-Fi stuff in a later video. We can show you how to hook it up, and we can help you troubleshoot a little bit later. Let me turn on the dryer now. Okay. So the dryer also has a few settings. We've got the normal, we've got a bedding setting, we've got a delicate, we also have a heavy duty, we got a small load, and we also have a download cycle on here. And then we've got some modifiers that you can select. One of the things that we do have on here is an energy saving mode. And one of the things that it always defaults to is the cycle that consumers are going to use the most. So in this case, usually customers will go ahead and always use the normal cycle, okay? So if they select the normal cycle, you notice how the energy saving button is selected right now. So what's going to happen is on the energy saving cycle, it saves about 15% energy. So you lose a little bit, but you only get half heating. My understanding of the way this one's going to work is typically in the energy saving modes, usually that first maybe 30 or 40 minutes during the cycle, it would cycle without heat. And then towards the end of the cycle, we would introduce the heat. And a lot of consumers complain about that because during the middle of the cycle, if they were to interrupt it and open the door, they would find out they don't have any heat. The first thing is, hey, my brand new dryer isn't heating, I want service to come out. Now, you don't have to use the energy saving cycle. What you can do is you can deselect it. You just take the energy cycle button, you just hold it in, and it's going to give you an audible tone, and then it's going to deselect it. So now every time you go into that normal setting, in order to get back to the energy saving, you would have to go ahead and reselect it. So now you don't have to worry they're going to get heat from the very, very beginning. This thing does have an install mode. What we normally get when we get product from the factories, we get the first ones off the assembly line. So there is a little tweaking to go on to these things. And one of the things I've noticed in the owner's manual, the way to get into the install mode wasn't the exact way. So I'm waiting for notification from the factory to show you how to get into this install test. And basically this is designed for two people. It's designed for you guys, but it's mainly designed for your installers and for the customer. And the customer can go ahead and they can check the vent. Now we have what we call flow sense on here. And flow sense, what it will do is it will allow the customer or notify the customer that they have a problem with the vent. In this case, what's going to happen is a number is going to come up, and it'll be a D number. They went as low as D75 on this one. Typically, it stopped at D80. So they got a D80, a D85, a D90, and a D95. The more severe one is your D95. That's telling you that you probably got a completely blocked vent at this point. I'll give you a quick rundown on how it works. It is looking at the temperature rise in your duct outlet, and it's typically looking for a 65-degree temperature rise. So one of the things that you cannot do is you cannot run the install test while the dryer is hot. You're going to get false readings. The second thing is where it's located at. A lot of times they'll take this dryer and they'll put it in a location that really is out of the ordinary. So one of the things is maybe it's in a garage and you're in a very hot climate. That garage can get pretty hot in the summertime, maybe 100, 110. So it might not see that temperature rise. So what you're going to get is you're constantly going to get these error codes. But on the newer products, what we've done is if you're sure that the customer does not have a problem with the vent and you want to avoid those extended service calls because the customer is saying, still coming up, still coming up, still coming up, you got to do something for me, you can deselect it. And it's real easy on these new ones. And basically what you're going to do is you're going to use the time dry and the signal buttons. You'll hold those in together and then you'll turn off. So I kind of missed a step. You want to turn on the dryer first, then you want to take that time dry and the signal buttons, hold them in together for about 3 seconds. You'll get an audible tone, and then turn your dryer off. And what it will do is it will only show if you have a D error code in the test mode. Otherwise, you won't get those nuisance trips. But what it will do is it will alert the customer if they have a more severe block vent coming up, and it will notify of them. Let me go ahead and we'll turn these off, and I'm going to quickly get into some of the install issues. Now, this comes this way, all right? When we uncrated it, it had a wooden crate because it came in from Korea. That's probably not going to be the case when you get it, but it's got a big cardboard box around there with foam and packing and all that other stuff. So when the installer does open it, this is how it's going to come. Now these two, they weren't meant to be unstacked, but they can be unstacked. You can go ahead and you can pull these two apart, especially if you've got a tight area where you're going to try to get into and get these installed. So a couple things that come with the install package is, let me gather these real quickly, and you've probably seen all these things already, okay? We did have our fill hoses coming in there, and we did have the owner's manual and the install guide that came with it. So that's something you want to leave with the consumer. It's got your gooseneck for your drain line. And you got this little package here. This little packet has a few things inside here. One of the things right here is a little wire tie. And that little wire tie should go on where your drain is. Never push this drain in more than 4 inches in a standpipe. What can happen is you can create a siphon effect. And basically after your first fill, without that air break in that line, what you'll be doing is siphoning the water out as fastly as you're putting it in, and so that'll generate a service call. So make sure you don't extend this down into that drain pipe more than about 4 inches. So what this does over here is a little wire tie. This is used to secure this. So during that water being forcefully ejected out of the back of the machine, it doesn't flip it out of there and give me a problem. Now,
they can because I have it this way. But I want turn audio off. No.
The wrench has a couple different things. It's used to adjust your leveling legs, and it also has a 10 millimeter on there. And the 10 millimeter, what it'll do is it'll remove your shipping bolts on there. And then once the shipping bolts are removed, we have these little plastic plugs. Give me a second. Are we having trouble with audio? Something? We're good? We're good now. Now, the other thing on here is on the very bottom. I don't know if you can see it, but I'll go a little closer to the camera. There's a couple little standing discs on there. And what they were designed to do is if you have a slick floor, what you can do is there's an adhesive back. You can peel that and you can tilt your product backwards. And then you can glue this onto the floor. And then you can rest your leveling legs on top of it. Now, a big mistake when customers use that is they install these backwards. They'll take the sandpaper or the rough edge and they'll put it on the floor. And that can cause floor damage. So you want to make sure that if they're going to use those, they use those correctly. Now, believe it or not, we still run service calls with shipping bolts not installed. We tried what happened is the shipping bolts were left in here in the test mode, and it was disastrous. This thing was rocking all over the place. I kind of thought it was going to fall on top of me. Now, the last thing I want to point out is this, or this little Y connector. The dryer has a steam unit, and there's a little steam generator that's located in the back over there, and that's where the steam comes in at. So we need fresh water. So this will go on your cold water inlet hose, and one will go to the washer, and then one will go to the dryer. I'll give you guys a word of caution. You can select the steam cycle even though it isn't hooked up to the water. What's going to happen if a customer were to select the steam cycle and they didn't have water, they are going to turn the heater on the steam generator, and that's located in the back there. It's about maybe the size of a pack of cigarettes. It's about that big. And what will happen is, without any water in there, you are going to take out that heater in a relatively short period of time. So they're going to need a new steam generator at that point. So if the customer doesn't have this hooked up to water, just remind them of the importance of making sure it is connected to water. And if they don't want to do that, then just tell them that maybe in the future you might want to use the steam cycle. So make sure that before you have the opportunity to hook up cold water to it, make sure that you don't use that steam cycle. So that'll kind of save you a service call in the future. Okay. I've got a quick video on how to install this. So just give us a second, we'll go ahead and play it. And we decided to do this just to kind of save time instead of you watching me fumbling around and try to remove screws and everything. We just can kind of show you this video. I haven't seen the edited version, so I think what's going to happen is they'll show you about the shipping bolts in the back. And I think what will happen then is it's kind of going to get into how to service this thing if you wanted to test your components from the board without completely having to remove the dryer from that unit. So are you ready, Tim? I don't know, can you guys see this video?
No,
Okay.
we can't, John.
All right, just give us a second here. Dan's going to
Click on the little computer screen and it'll say turn on screen share.
Well, we have reinforcements coming, so we'll get this played for you. I apologize for that.
While we're waiting, does anyone have any questions for John so far?
Notice that different color.
Just turn your volume up on your computer, John.
Your volume is up all the way. Okay, hold on. Can they not hear it? So, could you guys hear the video at all? Anyone?
No, I could not. So I'm guessing if they can't, because I'm watching too. If I can't, they can't.
I can just do a voiceover if you want.
Yeah, okay. Yeah, that's what we have to do that. So let me turn this on. Yep. So you need to move it.
We know.
Ready? Give me a password.
Okay, I'll just go ahead and talk over it. I kind of explained to you what that little package was. That's for the consumer, for the installer to go ahead and remove the shipping bolts. And now we're going to get into basically, I believe, how to remove the shipping bolts from the back of this thing. So let's give it a second to catch up. So. Yeah, we're going to skip ahead about 3 seconds and catch up because I don't want to talk about the same thing for you guys. So now we're kind of going over the control panel, some of the features. Now, when you unstack this thing, what you're going to do is you're going to have to remove the control panel first. But what I'm doing is I'm going to the sides of the unit, and you'll see a little cap there. Don't remove those with a screwdriver. All you have to do is kind of push on the end of that, and what that'll do is that'll pop that open. And there's a Phillips screw on each side. So what we're doing right now is just removing those Phillips screws. So like I said, what it is just a kind of a little hinge door on there. You don't have to completely remove it, otherwise you will destroy it. So basically just use your finger to kind of press it on that to open that up and then remove that screw. All right, now the first time you remove this control panel, there is some felt or kind of a rubber gasket on the top. So it is going to be a little tight to remove it. So what you want to do is grab the top of it and pull it towards you. And it's got clips on the bottom, clips on the top. So we want to disengage the ones from the top, and that's what I'm doing right now, just kind of using my fingers to pull those out. Now we have two connections over there. There's one going for the dryer and one going for the washer. It's very difficult to go ahead and put those in wrong. They're kind of hokey poked, so you don't get the wrong one in there. So what I'm going to do right now is we're going to remove a couple screws. Now, originally what I said is remove 2 screws on both sides. You only have to really remove one because there's a little plastic spacer inside there. So if you remove both of them, that one screw was designed to hold them in. They're going to kind of fall out when you slide it back. So just go ahead and you can remove the bottom one. Don't remove the top one. So I think I was a little off on this when I first showed you that you do have to remove both of them. So we'll wait for this to catch up a little bit. All right, he's going to fast forward a little bit so we don't get bored watching the same thing. Okay. Now you're going to have to make sure this is pulled out about a foot from the laundry center, whatever you're working. So put some floor protection and get to it. And what I'm doing is you don't have to do this, but I'm tilting it so the camera can see it. There is a little bracket on the back, and the bracket is held on by 6 screws. So I'm going to go ahead and remove those 6 screws, and then you can see in the back where your hose comes in for your steam unit for the dryer. Right below that is your washer, your drain hose, and of course your vent in there. So we'll go ahead and remove these. And I can actually have Ed speed these up a little bit so you don't have to watch me removing all these screws here. So be a little bit quicker. So at this point, after we remove that bracket right there, the only thing holding the washer and the dryer together is just gravity at this point. So after that is removed, then what it can do is I can slide it back. There are some little high spots on there where sometimes you run into a little bit of a snag, but you have a little glide on both sides, and that little glide kind of keeps it center. It doesn't stick down that far, so it's real easy. If you're lifting it up a little bit, you can move it either left or to the right. And what I want to do now is I want to be able to get to the main board to service it. So what I'm going to do is actually push this dryer back. You're going to have to really push it back about a good foot. Don't worry, it's not going to fall down on you. It's pretty top heavy, but this will be a way for one person to go ahead and service this thing without having to worry about getting to that main board. Now, of course, if you were doing more extensive service on the washing machine, it might require another person to help you unstack that dryer, get it out of the way. I'll leave it up to you. This is also what installers would have to do if they would have a tight fit. So I'm going to go back a little bit farther, and I think we cleaned it up a little bit so we have it actually at the 1 foot mark to get to it. Now, originally what we had done was that main board was secured on with a little screw there. On this new production, they've taken it off, and if you notice a little farther back, and I'm going to point to that, that's a little locking tab, and what you're going to do is disengage that locking tab. Guys, I'll be honest with you, if you feel you'd like to get that board off of there, especially to replace, go for it, but it's really difficult. It's a real tight fit inside there, and you got to really do a lot of prying and pushing. So what I found easier to do is actually remove the cover. We've got some plastic clips on the top and plastic clips on the bottom. And later in this video, I'm going to clean it up a little bit more for you and show you an easier way to get more room in there so that you can get your meter leads down here. Now, while we're kind of getting that cover off, let me explain a couple things. If you notice on the top of the drum, you'll see something silver right there. That is actually a vibration sensor. They went back with a vibration sensor. They had one about in 2010, kept it for a couple years, and it disappeared, and now that's back again. So another thing I'll point out to you guys is we are now ultrasonically sealing the 2 halves of the tub. So it's not going to be able to separate anymore. So if you guys got a tub job to do, what you're going to do is actually go ahead and replace that as a whole assembly. So in that case, it probably would be a good idea to go ahead and remove the dryer off there to service that. The next video that we're going to show you after this is done is we'll show you, I'll clean it up a little bit and show you how to get to the main board, give you a little more room inside there. Now, if you want to go with further disassembly on this thing, if you worked on an LG front loader, the rest of the procedure is the same. So what you're going to do is at the very top, there are 6 screws. You're going to remove those 6 screws. Basically, you're going to remove the the boot in the front. You have that little spring cable. So you're going to use the LG tool to remove that. And then at that point, you've got 2 choices. You can either remove the 2 screws for the lock assembly, or you can reach inside there. You can disconnect the connector from the lock assembly. And then you're going to go down to the bottom where the little drain is. You're going to remove the screw for the drain, and then go ahead and remove that. And then there's 1 screw behind it, and then your whole front will come off. And then you can service things like the pump or different things in the front. Now, there's still a cover on the back, so you can go ahead and remove the cover off the back and get to it. Like if you're doing your rotor or stator, there is no Hall sensor anymore. Hall sensor has been eliminated. And so we'll get into that when we get a little electric diagnosis. Now, what I did is I popped the cover off, and that's a sub-PC board. And basically, that's a board where we have communication between the main board and the display boards. So we're going to get into a little bit of more on how to diagnose that when we get into the electrical components checking. But I just wanted to point out what that little PC board in the front was. Okay. And I think you can go ahead and advance that, and we'll get into the next one when we get more into electrical diagnosis. Okay. Now, as far as servicing your dryer, I mean, technically you can actually service it being stacked. There's nothing you have to do on that. So what we can do at that point is you can go ahead and, for me, I'm going to have to use a ladder or something. I'm not that tall where I can see the top of this, but we have a metal barrier up on the top here. And what you guys are going to be doing is just remove, I believe there's about 12 screws, and that metal barrier will come off. And your main board is right there. So you can do your component checks right at the main board. What's nice about that board is there's no cover on that one, so we can actually get to those electrical connections quite easily. Now, another thing that's available for your option is if you wanted to get the dryer off there and you still only had one person, there's the other option of completely disassembling the dryer. I would use that for extreme cases where you have to get this thing repaired. Customer doesn't have any way of making it accessible for you, and if you want to really do something nice for the customer, you can go with that. Just please, 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 we don't recommend you trying to get this whole dryer down by yourself. I sure hate to see you get injured or do some damage when you're trying to remove that. But typically everything on this dryer is going to be kind of maintained the same. Now what we've got is a little video, and we'll show you how to do testing from the main board. Right after that, I'm going to show you guys how to get into the test modes on here. So if you want to do any cycling on the test mode, okay? So I think Ed is just about ready to start that. Okay. All right, we're going to see if we can get you sound for this one. That way you won't have to listen to me. So just give us a second and we'll get that started. While we're waiting, anybody have any questions?
I went ahead and cleaned these up a little bit so you get a better view. I said earlier, you can use PC board. It's a little tight. It's hard to get there.
Can you guys hear it? Can you guys hear the video playing?
It's very muffled and distant.
All right, we're going to try to make one more correction on that, and I apologize. Let me know how this goes.
While they're working on this, does anyone else have questions? They'll, once they come back on, we'll have them address the part number for the tool, if there is one. It's like, here we go.
All right, can you guys hear the sound? Or is it still being muffled?
You're gonna have to talk.
I can't hear anything.
Yeah, I think you're gonna have to talk.
All right, so I'll try to talk over as best I can. So what I had mentioned was even though we have those needle probes that are very tiny, sometimes it's really difficult to get it inside those connections. And so what I was showing you was there's little plastic guards and they're clipped onto those connectors. And so if you're careful, you can pry those off, and that'll give you enough room to get into those connections so that you can actually go ahead and get your needle probes inside there. And when you're done, just remember just to snap them back in place. Now what I'm showing you over here is we have 2 relays, and those are a UL requirement. We have to break both sides of those relays, and they're going for your sump heater. So we have to break L1 and neutral. But one of the things I want to point out to is if you go to pin 1 on each of them, one of them has black wire and one of them has blue wire. That's where you can actually check for voltage coming into the main board. And that's important, especially on this unit, because right in back of that, on that same rail, we have a noise filter. The noise filter is connected to your power cord. Your power cord plugs into the wall. And so in order for you to not have to test the noise filter and the power cord and the actual outlet for a dead unit, we can actually go right to the those 2 little relays there, and we can check for the incoming voltage coming into it. Okay. So right now,
John, sorry to interrupt. There's no video. It's just a black screen. Is it supposed to be?
No.
1 second. Go back to I added 4.
There we go.
All right. So those are those little plastic guards I was telling you about. They're on each side, each one of those connections, and they have a little clip at the end. You got to be careful. It's easy to break those little tabs, but they were designed to hold those pins in there. And like I was saying before, that's a good thing to remove if you're trying to get into those connectors. Guys, one thing I'll caution you on, if you pull that connector away from the board and you want to do a resistance check, please do not insert those probes from the part that connects to the main board. Those are very, very tiny little connections in there, and you're going to damage them. We've seen situations where they came back to us because they couldn't be repaired. And when we pulled off that connection, you can see where that little needle probe was forced inside there, and that caused a poor connection. So only do your connections from the connections where the wire's at. So it'll prevent you from getting some damage. Next thing what I think I'm doing is pointing out what the little connectors do on your board. So like I said, everything on this washer can be tested from the main board. We have a section in there where we have communication, and that's the communication from the main board to that little sub PC board. The same connector that's on there also goes to your display panel, and so we can do voltage checks from there. Up in the top corner over there, I have your LED lights, and I also have a little connection where you can go ahead and test your vibration sensor. So I can get into a little bit of how to check your vibration sensor. Really, really, really simple. Also, your connections for your stator are also located up in that corner. You probably, in most cases, don't want to do a voltage check on there. You probably more or less do a resistance check. We can also check our DC pumps. Our DC pumps are located in there. We used to have a recirculation pump and a drain pump that used to run off 110 volts AC. These are now 3-phase DC motors, and I'll get in a little bit about how to check those a little bit later. And then the other thing we have over there is our connections for our fill valves. Our fill valves have also gone by not having 110 volts to anymore. These are all DC valves right now. That's a tendency. We're getting more and more into DC components on that main board. And then we also have a little bit over to the right, we have our lock circuit. And then we also have some connections that go to some of the other components on your main board, like your thermistor and also your pressure sensor. So you can also check those from the main board also. Now what I can do is we can continue watching this video, or what I've done is I've taken some of the components from one of our washers that has very similar components. And I think it might be easier, instead of watching this, I'll just roll that over and we can plug it in, and we can actually go back to live and we can actually show you how to do some of the component tests. Would that be okay with everybody? I think you got the intention here of how to get to that main board and how you can diagnose everything from the main board. But let's actually go to the components we have on a pegboard, and we can kind of show you how to check those things. So just give us a second, we'll switch everything over. I think that'll be a little more beneficial to you guys than trying to watch a video and me kind of talking over it. Maybe I can have Dan kind of position the camera for me so we can show you different things on here. So we get an extension cord and we'll go ahead and we'll plug this in. All right, there we go. I'm going to grab a meter real quick, and we'll go ahead and we'll do some checks for you. So just give me a second. All right, so we're back over here, and this is our main board over here. And let me unplug this for a second, and I'll remove those little covers, and we're going to show you how to check for incoming voltage coming into your main board. So let's unplug this for a second. And we have a couple little clips over here that we can disengage. So grab a small little screwdriver here, and we'll unclip these for you. Sometimes it's easier if you can pull it apart and take a look at it, trying to see where these little tabs are. So you see I've got one here, and then I've got one on the other side. And then I can open this up. Okay. And then I'll go ahead and put this back on. And then I can do the same thing with the other one. And then we'll snap this back on. All right, so I'm going to go ahead and turn this back on. I just got a little circuit breaker here. We'll power this back on. And got my little fluke over here. And we're going to check for incoming voltage coming into the machine. Okay. Now, Dan, if you can point out over here, when we first plugged this in, you see that little red LED light that came on? That's going to stay on for approximately 2 to 3 seconds. It's solid state relays inside there, so they come on initially to save power. What we're going to do is eventually turn that off. And that red little light indicates that we have 5 volts DC at the main board. And we use that 5 volts DC as a communication. So all of our serial data cables and everything will be using that 5 volts to communicate. And some of those things are like from your thermistor and from your pressure sensor. So let's go ahead and we'll check to see if we have voltage coming into the main board. So I'm going to set this for AC voltage. And I've got my neutral, which is on the blue wire here. And I've got my black wire, which is my L1 wire. So we can go ahead and we can check for incoming voltage to that. I got about 123 volts. Now you can also check that at your noise filter. Your noise filter does have a fuse, but like I said on this one, the noise filter is a little farther back. It's a little harder to get to, so you don't have to worry about whether or not this is good or bad, or your power cord is good or bad, because I do have incoming voltage at that black and the blue wire right there. Now the next thing is, we've talked about it over the years, is how this unit powers up and everything, okay? So show you a couple connections I've got over here. These, probably didn't see it before, but these are going to your stator. There's no longer a Hall sensor on there, so basically if we're getting an LE error code, one of the things you probably want to do is see if you can physically turn the tub by hand without any power coming to it. You can get an LE error code because something is binding that tub. Maybe something has got in between the two tubs, or maybe I've got a bad bearing. So the next step basically for an LE error code is we really need to check those windings on the stator. Let me go ahead and I'm going to do a resistance check, so I'm going to kill power really quickly. And it's always a great idea to unplug this from the main board. We'll go ahead and pull that off. These are those little guards I was telling you about. So see how difficult it is sometimes to get a meter lead down there. So what we can do is kind of carefully snap these off, and it'll give me a little more room to navigate my needle leads down in between there. So once the two clips are disengaged, then I can kind of pop these forward. Okay. Now all I'm going to do is a resistance check, and I'm looking for somewhere from 5 to about 15 ohms. So let's go ahead and we'll set this for ohms, and just choose any two colors. So you're going to do all three of them. You'll do red to blue, blue to yellow, and then red to yellow. And they should be pretty consistent when you're checking the three windings. So we'll go ahead and we'll check this. So I approximately got about, let's wait till it stops bouncing around a little bit. Roughly about 10 or 11 ohms. Let's do the same thing with the other one. About the same thing, about 10 or 11 ohms. And then we'll do the last one. Check to see what we got there. So these should be consistent when you go from one to the other. Now, if your stator is coming out okay, what I would advise to do is to go in the back over there and go ahead and take that apart and look at your rotor. There's a set of magnets on there. There's about 12 magnets, and we want to make sure that any of those magnets might not be cracked or disengaged. So that's another thing you want to check. If everything else coming okay, and the reason we're doing this at the main board here is we're also eliminating the wiring being a problem to our stator. So if everything, our ohm checks and our wiring and everything else comes out okay without a Hall sensor, the only thing we really have to worry about at this point is your main board. So your main board is more than likely going to be your issue. Now I said normally we do not have to check for voltage at the stator, but there are situations where we're getting the LE error code. And let me tell you what LE error code stands for. I'm going to put this clip in a little bit later. LE error code means I don't see rotation on the motor when I'm supposed to. This could be a situation where your inverter is not sending power down to that motor. You can check voltage there. This is DC voltage. Problem with these meters here is they don't like seeing pulsating DC voltage. So if you do want to read a voltage reading on here, set it for AC voltage. These meters will pick up alternating current, sort of like our pulsating current does, and we'll be able to get a reading. Guys, this is pretty high voltage. You're probably going to get some of the readings above 200 on these things, so just be careful if you are going to be checking for voltage down to the main board. Not main board, but to the stator, okay? Let's talk about some other connections over here. We also have some connections over here to our pumps, and our pumps are going to come in off this right here. Now, normally what you can do is this side over here with the brown, the gray, and the orange, this is going to our recirculation pump. And the other ones, do I have the right connections? Let me make sure I'm in the right connection. No, I'm in the wrong connections. These are the ones for your recirculation pump. this orange, the black, and the yellow. And on this side, these are going to your drain pump. So I can do two things. I can do a voltage check, or I can do a resistance check. Since I have this unplugged, let's go ahead and we'll pull this out of here, and then we can show you what resistance checks we're going to get in here. So I'm going to see if I can get my meter leads down there. If I'm having difficulty, what I'll do is I'll pull out those little clip guards. And I should get pretty low resistance. I got about 3.3. And then when you do the other ones, they should be very similar. Remember, I got 3 windings down there. So this one is also about 3.1, 3.2, close enough. And then I'll do the last 2. They should be very, very similar. Okay. Now, the other thing I can do is check the recirculation pump. Pretty similar reading, about 3.2. Check the other 2. I also got about 3.2. And then the last 2. Okay. So that is coming out correctly. Now you can also, like I said, if you want to check for voltage coming to these drain pumps, and these are right over here. You guys want to see what the drain pumps look like. These used to be 110 volts. They are now 310 3-phase motors. There's one for each one of them, one for the recirculation pump, one for the drain pump. If you guys remember on the original ones, the 110 ones, they were different wattages between the recirculation pump and the drain pump. So one of the things that you couldn't do is you couldn't actually switch these over. I don't have any problem if in an emergency you wanted to get the customer going with a drain pump, you can temporarily swap those over. But the point I'm trying to make is on these new wash machines that went with these 310 3-phase DC pumps, these are now interchangeable. So you'll be able to use one in place of the other one. Okay. One thing I will mention on this that's changed from the original design is that if I got something that's jammed inside here, let's say a toothpick or maybe something had worked its way through the system and got stuck into the impeller, once the impeller isn't turning anymore, what's going to happen is your main board is going to stop sending voltage to these pumps. So if you're in the habit of maybe checking for voltage to these pumps, maybe if you can get into the test mode, you can test it, or if you were running a cycle, if you wanted to see you have voltage there, once it detects that the impellers are not turning anymore, that main board is going to immediately stop sending voltage to that pump. And so you might be under the assumption that the main board's the problem, when actually the problem is the drain pump. So at that point, you can actually pull these apart. There's a locking tab. You can unscrew it away from the pump. We can see if there's something caught on the inside of that. Now, I'll have Dan move the camera. We'll show you our fill valves right now.
The questions at the end, because I can't moderate and film at the same time.
Yeah, Dan had mentioned that he's trying to hold the camera, but he can't moderate. So we'll catch up on some of your questions as we go through here. So once we get done with this electric, I'll start answering some of those questions so it's still fresh in your mind. Okay, now these are your fill valves. These are now DC voltage. We say 12 volts, but technically they're around 5 volts. One of the things I will let you guys know is in the test mode, we send more voltage than we do in the regular cycle. So if you get a case where it works in the test mode, but the customer says the hot valve isn't dispensing hot water, it could still be a problem with the valve. Sometimes that 5 volts, even though that's the correct voltage coming to the valve, isn't enough to actually pop that valve open. So just don't always assume because we're getting working in the test mode that it is going to work in a normal cycle. Now you guys, if you want to, if you pull these connections off of here, 9-volt battery will actually energize these things. Once again, it doesn't always guarantee you that there still isn't a problem with these valves, but we can test them with the 9-volt battery. Or of course, once again, you can do resistance checks on these. You can also do voltage checks, and you can go ahead and you can do it at the board. I'm getting approximately about 26.2 ohms, and it's going to be identical readings for all of these valves. So these are color coded. Red is going to be a separate valve. then we'll have 3 that go to your main wash, your pre-wash, and your bleach. We do not have one for the fabric softener. The fabric softener is a combination of the bleach and the pre-wash valves. So they actually energize both of those. Those 2 streams will collide and it'll force it into the detergent dispenser cup. Now over here is our door lock circuit. We can test the door lock circuit at the board. We can also check it at the door lock, but let's be honest with you, it's very inconvenient to get to this. How are we going to operate the washer with the boot off in order to get to this? This is farther down. I'm not going to try to force meter leads in here that I can't even see. So in this case, if you're checking that door lock circuit, it's probably a good idea to really check it at the main board. Now let me show you a couple things on here. Let's first find that circuit for you, okay? So typically on some of the older design ones, what we had is we had 4 wires in here. Because what we used to do is we used to take that common wire, which was the black wire. It's now been changed to a yellow wire, and that was your door monitoring circuit. And what we used to do, and we had a drain pump, and we had fill valves that were 110 volts, what we would do is when we close 4 to 5 to complete L1, and in some cases we completed neutral to that circuit, they would complete one side of the line to, let's say, your drain pumps, common to your fill valves before it went back into the board. And we call that the monitoring circuit. There's a component inside the board. It's basically a transistor that's looking for if the door is closed. And all it is just looking for high to low voltage. And it's a low voltage signal that'll ride on that high voltage wire. Now, if you want to check it, it's real easy to do. Now, let me explain a couple of the other wires here. The other 2 wires is we have an orange wire and we have a blue wire. When you power up this machine, what they're going to do is they're going to send 120 volts. So all I have to do is hit the power button. The main board will then send 120 volts to that. And what that 120 volts is doing is there's a couple PTCs in here. We have what we call a heating PTC, and then we have a protective PTC. Now, the heating PTC, without getting too technical, basically what it's doing is it's right under a bimetal. So the heat that's generated by that PTC is causing that bimetal to slightly rise. And you can let it sit there for weeks and months with that 120 volts. It will never get any higher than that because that has a limitation on how high that bimetal can raise. So what we do to raise that bimetal all the way up in order to complete the contacts between the red and in some cases the black wire, in this case the yellow wire, we energize a solenoid. And you guys probably heard that, you hear that. So through this same 110 circuit that we're heating up the PTC relays, we are going to energize a solenoid inside here. The difference on that solenoid, and that's why even though we have 110 volts there all the time, we don't energize the solenoid, is because the solenoid is 2 things. It's voltage dependent, which means it uses 110 volts, but it's also frequency dependent. It isn't 60 hertz that energizes that solenoid. They have a different frequency, and that frequency is generated through your main board. Through the same 2 wires that we're heating up the same PTC relays, we'll introduce a different frequency to energize it. And that's that quick thump that you hear when that door closes. Let me plug this back in and we'll turn it on, and you guys are probably going to be familiar with that sound. So let's go ahead and we'll switch this back on. And then we'll go ahead and we'll power this up. I'm going to select normal, and then I'm going to hit the start pause button. And just listen for that little thump. Okay, you guys hear that? And what I'm trying to do now is I've got the rotor on the bottom. We don't have it hooked up to a load, so that's why it sounds so kind of funky. Okay, so let's go ahead and we'll de-energize this. Now, a lot of times what you guys are going to get is a DE2 error code, or on some of the older wash machines, you'll get a DE error code. And basically, that's a door error. That's telling you that the wash machine didn't sense the door as being closed. Okay, so you have to determine, where's my problem? Is my problem in the door lock circuit? Or is it a problem that the door isn't closing right and the little latch inside there isn't causing that circuit to close? Or do I have a problem with my main board? Now, an easy way of diagnosing this is, let's show you how to do this. This is going to be really, really simple. So I'm going to kill power for a second. Now what I'm going to do is this L1 circuit over here is really coming off of your noise filter. That's your L1. So I can really go right to this relay here. So I'm going to pop up one of these little meter leads and I'm going to plug it into there. Okay. And the next thing I've got over there is when this switch closes, I'm going to close red to yellow here. So all I have to do is really go right to this yellow wire here. So kind of work this down here, make sure I got a good connection. Put this back up here. All right. Now, when I plug this in and turn it on, I should get 110 volts right there because basically I'm coming off the noise filter. This is a little switch here. The switch is open, so I should read line voltage at that point. So let's go ahead and we'll fire this back down. Let me change this to AC voltage and then we'll fire this back up. Okay, so I've got line voltage there. Now, how you're going to determine whether or not my problem is in the door switch, maybe the door switch is doing everything it should. That will go to 0 if the contacts that are in this switch closes the red and the yellow wire. So I'll have Dan look at the meter here, and what I'm going to do is I'm going to power this up. Okay, still got 110 volts there. And what I'm going to do is I'm going to power this up, and you're going to hear that little once again where that solenoid is energized. It moves the cam to the high spot, allowing those contacts inside this door switch is closed. If everything is functioning correctly in this door switch, what's going to happen is that should go to 0. So let's test that real quick. Okay. Now, all your board is doing is it doesn't know that the door is closed. All it's seeing is that voltage off that transistor in your main board went from high to low. And we're only talking about 5 volts DC. There's no way we can check that. I'm not that good in electronics to tell you where to go to that, even if I can get to it. But this is all I'm worried about. I just want to see if those two contacts closed. So if I'm still getting, and I'm going to take the power off here. So if I'm still getting a DE error code with this situation right here, the only thing that could be bad is your main board. Now, before you guys replace the main board, there's something that could have taken the main board out. And we see this a lot on the older wash machines that used to have a common on your fill valves and a common on each one of your drain pumps. And what I normally seen in those situations was I've seen a lot of shorted drain pumps. So that's really easy to check. We can check right at the main board to see if we got a dead short on the drain pump. Go ahead and replace that, and then go ahead and also replace your main board. So it's real easy to check that circuit inside there. So other things I can check is, like I said, you can check the fill valves. If I don't have an error, I can always get into the test mode and I can test the different components inside the test mode, and that's what I'm going to do on the stack unit. We're going to show you before we go how to get into the test mode. The last thing over here is your pressure sensor. This uses frequency to determine what the water level is. You can actually test these. There is a common terminal. In this case, the common terminal is your violet wire. The other 2 wires are 2/2 of an oscillator. And so basically when I go from violet to orange with power on, I should get approximately anywhere from about 2.5 to 3 volts DC, and I should get the same thing from yellow, from white to violet. So let's go ahead and we'll switch this to DC voltage, and we'll go ahead and we'll quickly check that for you too. So. All right, what I got to do is I got to power up the wash machine. I do need power for this. And we'll put our black lead here, and then we'll go to the orange lead. And I got about 2.9, and then I'm going to do the same thing when I go to the white. It should be very similar. Let's see if I can get a good connection in here. It's going to be a little stubborn, but you should get about the same reading from both of them. Okay. Now remember a couple of these things like thermistor errors. When I got an open or shorted thermistor, if I have a pressure error, which is a PE, Or if I got a door lock error, these are 3 error codes that are immediately going to shut your machine down. They present a hazard for the consumer. And a couple things is, you don't want the washer to operate with the door not locked. You don't want to be able to operate a cycle if I can't decide how much water is going into the machine. And I also don't want to go into a cycle if I can't determine what the water temperature is. So these 3 errors, TE, PE, and DE, are going to shut your machines down right away. Now, these are all used as inputs into your main board to let you know that I have a problem. You typically don't get a pressure sensor error, but you might get a drain error. You might get a fill error. And they're all using this pressure sensor to determine what the frequency is on the water level. So then I'll show you how to do this. This is going to show in the test mode, but we also, in some of these cases, have hidden buttons where we can bring up these features in a cycle to show you what the frequency is, to show you what the spin speed is, and also to show you what the temperature of the thermistor is. This thing is just giving an input to our main board. And so an empty machine will have a frequency of 25.5. This will display as 255. Now, as the water level goes up, what's going to happen is that frequency will drop. The lower the frequency, the more water in there. In fact, if the frequency were to get up to 2.13 or 21.3, excuse me, or it'll display as 213 on your main board, that's what we call flood state. And flood state is going to recognize that, and it's immediately going to lock your door. It'll flash an error code, but more importantly, what it will do is it will activate your drain pump to get rid of the water so we don't have a flood in that room. This can also determine whether or not the water is draining. So what's going to happen is you just left that cycle. The frequency, depending on what you have set at, might be at 23.9 or maybe 24.8. Remember, the higher the number, the more water we got in there. So what's supposed to happen is as the drain pump comes on, that frequency should start to rise until it gets up to 255. So this would let the board know that I didn't see the frequency change. And it usually takes about a good 10 minutes, and that'll generate that DE2 error code. Okay. The last thing over here is your display. And a lot of times we have to know whether or not we have a problem with the display board or not. So there's a couple of places you can go for some voltage checks, especially if everything passed okay, but I still don't have a light on my display, or I have a different problem here. Now, the first 2 wires are your communication wires. So that is allowing your main board to communicate with your display board. Now, the customer has to be able to choose options. The best way I can tell you to check it is if you put your meter leads across there, this should be pulsating voltage. You guys notice that bottom thing on the bottom, that little hash thing, and you see the way the voltage is bouncing around? That's really what you want to see. That's communicating. When it's steady and it isn't pulsing and you don't see these little hash marks moving back and forth, I've got a problem. So you have to know whether or not you have a problem maybe with a cable or you have a particular problem with the board. So your main board is sending out 5 volts DC. That's why this is pulsating like that. If you want to check it, and these are good, but I can kind of give you an idea. If you take your black lead and you go to the red wire, which we're going to use as a ground, you can determine what's one of these. So this is really your main board's transmission. You can see it's close to 5 volts DC. If that was a problem where I had a bad connection or the board wouldn't be sending out that 5 volts, I would either see a 0 or 5 volts DC there. Next thing, I'm going to go to the brown wire, and I'm going to get a similar reading on there. So let me try to work this in there. And you can see it's a little less voltage, but it's still pulsating. You'll get the same thing. Either you get a 5 or a 0. Remember, on one side of it, it's transmit. When it gets to the other side, it's receive. The same one that was receive is going to be transmit on the other board. So they're just opposite when they go from one board to the other. Now, the other thing that you're concerned about, especially if I don't have a display, let's see if our main board is producing, in this case, 12 volts DC. I can test it from here. I can test it from the display board, or I could even go to the little connection that joins the 2 together. So I'm going to take my black lead, and I'm going to go to red, and I should get approximately about 12 volts DC there. Okay, so I got about 13.5. That's good. And the next one is my communication voltage. I go red to yellow, and this should be your 5-volt signal. That should be your 5 volts that I'm using for my thermistor and my pressure sensor. Okay. We also use that whenever we have some type of signal. Okay, so this is a good way of determining whether or not my problem's in my main board or my display board. So let me open it up for questions. I know we're getting close to that hour mark. But if you guys have any questions, Dan will read them off and we'll try to answer it to my best of my ability for you guys. So.
You're in the screen. I'll read the questions. I'm going to back up to the first questions that came in.
Can you guys hear Dan?
Yep, we can hear him.
All right.
Okay. Sorry, I had to go all the way back.
There's a few of them there.
Yeah, it went.
Yeah, sorry, we were supposed to be keeping up.
Good. No, that's good.
Track here. I'm sorry.
Okay, about
good.
About sounds. I don't know if the video was being recorded or not.
Yes, this is recorded, and we will have it on our website for replay.
Okay.
And we'll see if we can work that video into there so you can see what that is actually saying. And I apologize for that.
Okay.
We understand.
When will this hit the market?
This is actually out there right now. If you go to the LG website, it does have a list price, and it is available for sale right now. I don't know where it's being sold at, if that's part of your question, but I know it's already listed online. So might be seeing it at your local store pretty soon.
How long have you been with LG?
I've been with LG since October of 2009. Very fortunate to work for LG. It's been a great company for me, and I love the opportunity that they give me here. So,
can you repeat the model number and the alphabetical meaning?
Okay, it's a W as whiskey, K as in kite or Ken, E as in Edward, X as in X-ray, and this is a 200. Now that 200 could change if there's different features. They might go to a 300. Right now, it's just listed as a 200. The W in that model number, when we're dealing with laundry, stands for washer, because this is listed as a washer tower. Now the K, we're assuming, we haven't got any notification, but that's new to us. We've never seen a K come up before. We're assuming the K stands for tower. So maybe in the future, if you see that K, that's referring to this combination power stack unit. Now this has been around for a while. Whenever you're working on a dryer, if you see an E in the dryer name, and you'll typically see maybe like DE or DG, and E stands for electric, and the G would stand for a gas version. So in this case, this is electric version of it. And the X, whenever you see an X, that means there's steam. So this one has a steam generator in the dryer, and it has a steam generator in the washer. Let me take that back. That's not true at all. There is no steam generator in the washer. For the last few years, what we've been doing is we've kind of gotten away from the steam generators, and we've gone into what we call LG steam. Basically, we already have a sump heater on the bottom. So if a customer were to select the steam cycle, what we would do is we would go ahead and get the clothes wet, and then we would partially drain the water, leave enough water that it's actually covering the sump heater. And then when we're ready to get into the steam cycle, we would monitor that temperature with our thermistor, which is part of the package that goes with the heater. And we would turn on that heater and boil away that water on the bottom to create the steam. So this way it gives the customer that added feature of being able to have steam, but they don't have to actually spend a lot more money for that unit that had the steam generator on there.
Will the freestanding single steam dryers be going with the Y and hose, or will they be staying with the reservoir as in the past?
That's already been out there. I believe it's been out there for a few years right now. We've gotten rid of the steam generators, and we've gone into what we call that little package generator, which is in the back. And believe me, I can't stress the importance, like I said earlier, make sure that before the customer energizes that, there are no safeties on there or anything. It's not going to recognize there's water in there. They are going to ruin that steam generator if they try to activate that without it being hooked up to that cold water. So there's actually a solenoid there that actually will fill that steam generator up.
Is this a two-man job to service this unit?
It all depends what you're doing. If I want to do anything in the front, like get to the drain pump or get to the recirculation pump or change the boot, or maybe I have to change the front or do anything in the front, I can actually show you like before. Don't even have to move the dryer back. What I can do is I can pop the control panel. It's real simple. Just do those little covers, just push those in, remove the two Phillips screws, go ahead and disengage the control panel. And we'll go ahead and move the two connections from there. And then what I can do is, like I said, if you want to get this front off, what you're going to have to do, and you can start wherever you want, but I would start here. I got 6 screws across the top, and you'll see them. They're quite evident. You're going to have to remove your detergent dispenser. That'll be a locking tab. I've got 2 screws right here. And then what you're going to do is you're going to pop open your door. You're going to have to remove the front boot. So we have this little tool for that. Makes it convenient. And we will get you the part numbers for these, okay? So this, you can go ahead and you can remove that boot. And what I'm going to do is push the boot in. Now, you have a choice on here. If you want to leave this here, you could. All you have to do is, since the boot is open, I can stick my hand there and I can disconnect the connection that goes to the door switch. Or if you want to, you can leave the connection on there and just remove the 2 screws. And then next thing, I'm going to go down here. I've got this little clean out trap for the consumers. So basically, I have to remove this escutcheon. So I've got some screws here. Remove these 2 screws, pull this drain hose out. This cover will pop off. And I got 1 more screw. We put that bottom screw here because we got some vibration from this front panel. So you have to remove that screw. You can now remove this whole front section here. Okay, so I didn't even have to move this out, or I didn't have to do anything with the dryer. I can go ahead and service the boot if I wanted to. I can service my pumps. That gives me a little more room to work on that. Some of the things you can get from the back, like if you wanted to get to the rotor and stator, I'd have to remove the rear cover. That hasn't changed. It's the same cover back there, and I can get to some of those components. But one of the things that you're probably going to require, and I would strongly suggest that you use 2 people for this, is getting the dryer off to maybe do a tub job. Remember, this is no longer separating 2 halves of the tub. They're going to come as one assembly, so that thing's pretty bulky and heavy. If you don't feel you can handle it, it's always a good idea to have 2 people to do that. Same thing maybe even with your struts down on the bottom. Maybe to replace those, it might be a good idea to have somebody help you get the dryer off there in order to service those things. Or maybe if you're good enough, you can have enough room from the back to kind of work those off of there. So I'll kind of leave that up to you. Some of you guys find ingenious ways of servicing things without having to do a lot of assembly. So.
Okay, stay over there.
Okay.
I'm keeping you in the screen with the. So anyway, where'd you go?
I'm here.
Oh, okay.
Grabbing some milk and talking.
All right. They both operate out of a single control board.
Well, originally what happened was when we got this unit, and I'm going to start from the beginning. We got one of the first prototypes that came up here, and what we had to do is we had to hook up a pigtail for the 220 line. And basically what they had is they had a line that went down here connecting power to the washing machine. But I think the question you're answering is, do they work off one control board? No, the control board that I showed you earlier was strictly for the washing machine. There is a separate control board. Remember, these are basically a separate dryer and a separate wash machine that's just been joined together. The only thing that they really do share is right here. Now, in this latest production, if you got the electric dryer, what you're going to have to do is the installer will have to hook up the pigtail in the back of the 220 line, but the washer has its own power cord, and it's attached to your shipping bolt. It's got a little clamp there that you're going to remove to plug that in. So you've got separate power going to the washing machine. So
You got a request for the part number for the tools you talked about?
yeah, I'll have to look those up. And what I'll do is I'll send an email to Sarah, and maybe she can get those part numbers out. Or if you want to shoot me an email, I'll give you my email. And I just don't know them offhand. I'd have to look them up, so I don't want to waste any of your time. But these are available from your parts distributor. We actually have 3 tools. We've got one for the outer boot, we've got one for the inner boot, And we've got another one, whether or not you want to use it, I was never really that impressed with it, but it's to remove the little pins on your dampers. I could do the same thing with a socket and a pair of channel locks. So I'll leave it up to you. I'll give you all 3 part numbers. And we also, if you're interested, I can also give you this. There's a part number for this tool if you want this part number for this tool. But you can probably use a 10mm socket. Works the same way. So.
Will you be able to reset the high limit fuse from the back tail?
No, there really isn't really any access panel in the back. If you wanted to do that, and really, trust me on this, if that high limit fuse is open, that's a safety. Only reset it for testing. If that thing opened, we've got a problem. We really need to do a couple things. First of all, the only reason that one opened, that's the last line of defense. So that one only opens if you continually had stressed out your high limit thermostat. Your high limit thermostat then failed. What would happen is we would take over and use that thermal fuse on there. And so some of those are resettable, but only use it to test it, please. It's not worth burning down somebody's house just because it was easy just to push that button in. So figure out what took those 2 thermostats out in the first place. A lot of times it's venting issues, okay?
The skinny leads are universal. Do you have a part number?
I do. I can also include those. And where I bought those at, it was Granger. I'm pretty sure if you go to Amazon, you can find them on Amazon too. They are pretty universal, so they do come in handy. So,
one word of warning: one set is 60 VDC, and the other set is rated for 600 VAC. So there is you want the set that'll go up to 600 VAC.
Yeah, some are designed for electronic work, and some are designed for what we do with higher voltages. So. Sure hate to see you invest that money only to get your meter leads running.
What is the purpose of the binder clips you used?
All right. Remember when I took this apart and I had this pushed out over here? This control panel is just kind of precariously floating on the top here. So if I'm working on that board and I go like this thing is going to fall down, and I could scratch this or I could damage something. So I was trying to figure out a way to hold that in place. Now, I was going to originally use those clips to clip it to the frame of the washing machine. I can't get it on there. The only thing I noticed was there was that wire connection that plugged into where the washer was. And they also went to the vibration sensor. So what I did was clip that onto there. So it kind of kept this from falling down. I mean, the main purpose was I didn't want to damage this thing if I accidentally bumped it or something. So.
Very nice to remove the hall sensor. Is illuminating my question. Will the wire still break inside from vibration?
Well, don't forget we had different gauge wires, when you're talking about one to the other. I shouldn't say different gauge, they were actually the same. But we had a problem when we took those connectors and we put them in a plastic bag. Sometimes what you get is condensation inside there. The condensation stresses out those connectors, so eventually that thing is moving and eventually they do break. So you made a good point. One of the things you want to check is before you start condemning main boards and hall sensors is we want to make sure that we don't have a loose connection. So that's why I always say check from the main board, because technically, when we're using the hall sensor, we're using 12 volts DC. We're sending that down to the hall sensor, but we need a signal back. So our signal backs come from the red and the blue wire, and it's typically pulsating about 11 volts back to the board. So the idea is checking at the main board. I not only check for voltage down to that hall sensor at the main board, I can also check for those feedback signals too. So if you're checking that and you're going to reference it to your ground, which is your gray wire, and you're going to go to the red wire, and then you're going to go to the blue wire, when you're rotating that tub, that should be pulsating DC voltage. If it's not pulsing, if it's a fixed 9 or a fixed 10, then you need to go ahead and check to see if the hall sensor is the problem or if your wiring is the problem. Now, one of the things I said, in some of our washing machines, we have hidden modes, and basically it's usually delayed wash, and in this case, you're going to be checking for speed from your wash tub, okay? So if you're in a normal cycle, this thing is spinning, and you go and you hold those two buttons, and your display, which is supposed to tell you the RPMs that drum is turning, and it's saying 0, you're not getting a feedback from that Hall sensor. And this will sound, guys, just like a bad bearing. This thing will be roaring, this thing will be shaking. Customer says it doesn't spin like it used to, and you'll swear you got a bearing job, but when you take it apart, there's no evidence that water's ever been leaking. So really suspect your Hall sensor at that point, and that's one way to quickly check that, because if that thing is spinning, I should be seeing RPMs on the screen. If I'm only seeing 0 on there, then that gives you an indication I'm not getting a signal back, and this thing doesn't know how to control that at that point.
I believe this question came in while you were covering the pumps. Are they the same motor?
They are. Now, with that said, if you have the AC ones, they run off 120 volts. There's different wattages. You do not want to put the recirculation pump in place of the drain pump. You can do that just for like short times, like if you don't have that pump and the customer really has got a lot of clothes building up. So temporarily you can switch the two. Just don't leave them that way, because they are different wattages. But on these new ones with the 12 volts DC, these are completely interchangeable. Okay, you can take that recirculation pump and you can replace it with the drain pump.
Okay, since we didn't get to this question at the time, I'm not sure where he was referring, but it says, then you cannot know if the water valve is bad. And it might have been talking about it's 12 volts during the test, but it's only about 5 or 6 during actual operation.
Yeah, so the simplest thing I can tell you is you can check it from the board, or you can check it right at the valve itself. So I typically says that in a normal cycle, we're going to send 5 volts DC there. But my point was, you go into the test mode to check it. We don't send 5 volts. We send higher voltage. We send about 10 volts. And that might be just enough to go ahead and open that valve. There might be something with that coil that can't pull up, that can't create that magnetic field to pull up that plunger to open the valve. So what I would suggest you do is you just put your meter lead right at that valve. If you've got 5 volts DC there, that valve should be opening. If it isn't opening, you've got a bad valve. Don't replace the board at that point. Just go ahead and replace the valve. Okay.
All right. So we will see more loading down situations.
It's possible. Yes.
Okay.
Especially on the DC voltage ones.
Can you take that drain pump apart?
Yes, you can. Remember, the housing for both the recirculation pump and the drain pump is a plastic housing, and that's also where you see that little clean-out trap in the front. But what it's attached to it is actually the motor. So it has a locking tab. So disengage the locking tab, and I believe those are counterclockwise. You just turn it counterclockwise. It's got a rubber gasket in there, so you're going to really have to grip this thing and turn it, but it will separate. So you can separate and see if there's something jammed up inside there. Maybe you got something that worked its way through.
You said the lock is lower down on this unit?
The lock.
And that was a question mark. Evidently the door lock for the washer.
No, the door lock for the washer is still in the same spot over here.
Okay.
Okay. I just have it. That's a mock-up unit we put together for training. So we just put that up in there. But the point I was trying to make is, if you're going to text that lock circuit, it is very, very difficult to get to these connections. First of all, the connections are facing down. So I would have to try to get my hand all the way down here and then try to see if I can work my leads in there and not even knowing where they are. So it's probably, like I said, just go to your main board. If you wanted to actually get to it, you'd have to take this boot off, but then I couldn't operate it without the boot on. So like I said, the main board is probably the way to go.
Somebody asked, yes.
Oh, I was just saying, we need to cut it off. I'm sorry, it's been an hour and a half. We've
Okay.
and is there a way we can type these questions up and send them to you, John, and respond to everybody?
Yeah, I'll give you my email. Okay, it's real simple. It's John, John, dot, you got to put the dot in there, and the last name is Stanton, Stanton, at lge.com. So LarryGeorgeEdward.com.
I just put that there. And then can you say the model number one more time so I can type that as well?
Of course. W as in whiskey, K as in Ken, E as in Edward, X as in X-ray, 200, and it's going to have an H. They use an asterisk mark because we have different colors, and then A. So really the last three alphabets aren't really that important. So if you're looking this up on GLMS, just go with the WKEX200 and it will come up. So
Awesome. So Abe was right. All right.
Mhm.
Perfect. Thank you
Well, I
so
wanna
much
thank
for your time.
everybody. I'm sorry for going long, and I'm sorry for all the problems we had. I think we need to work out a lot of little bugs. So I
You know what? It
apologize.
was great for the first time. We really appreciate you guys coming on and doing this, and we look forward to more in the future.
Yeah, let us know what you guys want. We have a new washing machine. We have a top-load washing machine that now has an agitator if you want to see that. We've got a brand new dishwasher that has a water softener and an automatic door opener. We can talk about that. We have quite a few new things. We have ranges that now have air fry inside there, and it also has a knock-on door. So we have a lot of new things to talk about. But maybe what you guys are interested in is the old stuff. So let us know if you want the old stuff. We'll bring the old stuff back because maybe that's what you see more than the new stuff. So let us know.
Awesome. And everybody too that's attending, if they have suggestions, we love to hear it. And John will be talking soon, and we'll make sure and get this video up on our website, as well as the links and the part numbers as soon as we get them listed. And thank you, everybody.
Yeah, thank you. Be safe out there, guys. We really appreciate your job you're doing out there. You're under tremendous strain and stress with all this going on. So we want to let you know we really appreciate that. Thank you.
And thank you for bringing training to them. They definitely need it.
Hopefully we'll see you guys next year in the road. So.
Thank you. Have a great day.
You too.
Yep.
Thanks.
Bye.
Sarah. Thanks, Sarah, for this. She's the one who arranged everything. So.
Oh, my pleasure. Thanks for working with us.
You
We'll see you soon. Yep.